Good morning, Tom. It's a pleasure to meet you today. How are you?
Good morning. I'm doing well, thank you. And yourself?
I'm great, thank you for asking. I'm excited to connect with you today and see how our software and our services can help you with your goals. But more importantly, if this is something you and your company can make use of. I'm curious, how did you stumble across visTABLE, and what are the reasons you are looking for a software like this?
Well, I talked to a colleague of mine about a new project we are currently planning and developing. We want to expand our production by building a new facility, and he recommended looking into your software. I researched the internet and also found a couple YouTube videos that explained some of it. What really caught my eye is the simplicity it brings or tries to keep in such a complex planning process, because we really need to create a solid layout of the plan, ideally also in 3D, to present the concept to the necessary decision makers, as well as provide the architects with all the precise data for the building. And yeah, after that, we would also like to restructure our already existing production as well. We definitely have a lot of optimization potential in these areas, and I'm looking forward to seeing how this can help us.
Yeah, definitely. I am convinced that visTABLE can support you with these tasks very well. So how do you currently plan the layouts? Do you use any software for this? And if so, is the data based in 2D or even 3D? And under what criteria do you design the layout? In the existing layout, it's probably more based on the available space conditions, or is it already oriented towards material flows?
We still have old CAD layouts in 2D, which our colleagues from the construction department created some years ago. However, it is no longer up to date, and it is always a hassle to have the new changes incorporated through the colleagues in construction. So sometimes we just even plan stuff in PowerPoint or Visio real quick. The most important thing for us is user-friendliness. For new machines with data from the equipment suppliers and overall, it would just be great to have the entire layout in 3D so that everyone can visualize it better.
I see. By the end of this meeting, you'll have a clear understanding of how everything works, the ins and outs of our tool, the thought process and efficiency behind it, and overall the value we can bring to your organization. Let's jump right into it, shall we? Feel free to ask questions or share any insights you have during the presentation.
Sounds good.
Basically, with such a large project, it is about bringing all the involved parties together in the best and most efficient way. visTABLE should be a tool that is easy to use intuitively and where you can also work participatively. Because for outplanning, there's always several people involved. However, the participants often come from different work areas and have different program knowledge, and the principle of paper and scissors is quite suitable in that case. You are at a table and can discuss different layout aspects with each other in a simple way. With visTABLE, we have converted the whole thing into a digital form, because this is really about layout planning. What we're seeing here now, where we're looking at the layout, in this case now an example factory, classically viewed from above, and just like with paper and scissors, the elements there can then be moved in position or slide and rotate in the layout. To give everyone a better understanding, there is also a 3D representation that we see here, ideally on a second screen. It's good to always have the connection between 2D and 3D. Unlike from other programs, they are two separate views that are ultimately connected via this virtual camera, which I can now move here in the layout. And where I have positioned myself with the camera, I always see in the 3D representation as well. So questions like, where am I, and in which direction am I looking, are easily answered. Of course, I can also navigate through the layout relatively easily in the 3D view with the left mouse button, so both is possible. In the case of visTABLE itself, the most important points in development were, in our opinion, yes, you can plan in 2D, which is certainly also completely sufficient in concept planning. But the more detailed the thoughts mature, it is of course much more helpful if you can display the whole thing in 3D to a certain extent. Overall, it just improves communication and can help avoid misunderstandings because everyone can imagine the layout pretty simple in a 3D environment. And hence, everyone can also participate in discussions very efficiently. To put this into perspective, in the background of the example factory we see now, there's a small grid. The grid spacing is 1 meter, so that you also have an idea of the proportions, and you can also use it to immediately read the layout better. And in the next step, I would like to show you the different menus, and then also come to the functions in visTABLE. We have the main menu on the left. And here you have a few general functions in visTABLE where you can, for example, import existing DWG data, image files, or PDF formats. So no matter what stage the planned project is in, before jumping into visTABLE, you can always integrate it and continue with it in the program. You can save everything in different 2D and 3D formats. A simple way to make the data from visTABLE accessible to others is by using the viewer. But here in the viewer mode, nobody can change anything in the layout. You can also activate object snapping in the main menu and have access to help and support. Let's move to the general functions. Here on the right in visTABLE, we have divided these sections into 3 parts. There are a few general functions, then the creation functions, and the corresponding evaluation functions. You can easily find objects in the layout via Explorer search. Especially when the layout is larger, it is very helpful that you can either search for the objects by name, or that you search via the surface types here, or via the layers and filter out your objects accordingly. The layers also give you the opportunity to organize your layout. However, this is much easier than comparing it to a CAD system. You basically create a layer for everything that has to do with, for instance, transport, a layer for the building, where you now store the building elements, or a layer for the roof, where you can, for example, show and hide the roof separately. You can also lock these layers to protect them from moving, and you can also switch the visibility of the layers. This helps organize the entire layout. This comes into play very well with views, usually presenting different layouts. One would take screenshots and prepare a PowerPoint. We always keep simplicity and efficiency in the back of our mind. So for visTABLE, we wanted to avoid someone starting a meeting and then wasting everyone's valuable time by navigating the camera to the right viewpoint and hiding layers each time when moving from discussion point to discussion point. With views, you can simply pre-prepare views with a given camera position and hidden or shown layers, and switch between them anytime you want. That's how we started this presentation with this view I saved. The idea behind it is that you can navigate the meeting effectively and break down certain discussion points. So say, you start with an overview with a roof. Then there's an overview of the plant without the roof to take a look inside the factory. Same goes, for example, with the block layout. Now I've just hidden the block layout areas and all 3D objects here. Or I just jump to pre-assembly, where I then want to plan the workstations and find the ideal layout for my worker. To see how this saves time compared to moving everything now, I've also already set up a view of an empty area in this factory to jump straight into the next functionality. Here we are at the model creation functions in the model library. Here we can see on the right side the various catalogs that we offer with visTABLE. We have over 2,500 different models in different areas in the visTABLE library. It's all just drag and drop. So when I find the machine I want, I just drag and drop it into my layout. If you now remember the sightseeing flight through the factory that we saw in the beginning, the factory is 100% built, completely from models of the visTABLE model library. So these are all standard elements, from the forklift to the pallets to the racks, the machines, building elements, the exterior elements, the trees, everything. All this can be found in the original visTABLE library, which is available to everyone, and thus anyone build a factory like this very quickly. Of course, you can also import your own files as well. Step files, DWG, DXF, WRL, the list goes on and on. And so it is relatively easy to have and build the library you need. You can look up any model in the search bar by entering some general terms or specific words. You get a selection of the possibilities that you can position in the layout. And then, for example, you can drag the assembly table into the layout here, or right away add a worker to the assembly table as well. So bit by bit, you can truly visualize the factory. Now, you can already see from the alignment grid how the objects are positioned in relation to each other. Also, if you don't want to import your own model, but the model in the library doesn't exactly represent the dimensions you want, then you can adjust it here. You can scale it to make it more similar to the one you have. And you can use the dynamic menu on the left side via the properties and can actually store the sizes of the object here and adjust the shape accordingly. If I now want to align the objects to each other, I can, for example, use the Control key and drag a frame over the objects. Ultimately, I select both objects and have the alignment of the objects to each other as a function here. For example, if I think they should be aligned at the bottom of the line, I press the button here. And then maybe I also want to determine the distance where I say that both objects should now be 1000 millimeters apart, and I want to move the workbench. Then click to move the right side, and then I have positioned the workbench with a distance of 1 meter. If I don't want to constantly check the details in the function though, I can also drag and drop a dimension line in here that displays it right away. If you see the little dot here on the corner, it means the dimension is connected to the object. I can also switch between meters and millimeters again for the dimension. If the link is given, and I now change the position of the object, the dimension then moves with the object accordingly. And so I always have the reference to a corresponding distance. Another option, in case you don't have the exact model of your machine yet, would be to work with placeholders. In the block catalog, you can pick a certain block and also adjust the dimensions if needed. You can also turn this 2D block into a 3D block by adjusting the height here. It's very bulky and raw, but in case you want to make it a bit more accurate, if, for example, you have a unit attached to your machine, you can add this block next to it and group it into one. If you then have the same machine somewhere else, you could also easily duplicate it like so. A function that goes beyond pure geometric handling can ultimately also be found in the catalogs, and that is that we offer various symbols. This could be certain necessities in the area or next to the machine, such as escape and rescue routes, electricity, compressed air, and more. I gotta ask, how do you handle such information in your current plans or layouts so far?
That's a good question. There is currently no central location where this information is stored. Of course, the values are stated in the supplier documents. For older systems, it is usually on the nameplate of the machine, and our maintenance department usually also has some information about this. When I think about our last conversion project, it was quite difficult to get all this data together. If there is such a function in visTABLE, it would be very helpful for our work.
I see. For instance, it could now look something like this. If I now load the symbol for compressed air into it, then you can see in the layout, a small cube for 3D or here 2D, that there is a compressed air connection at this point. And if, for example, I now look at the attributes of the machine and say compressed air, unit bar here, and we usually have 6 bar, I could also connect additional attributes like compressed air consumption, plus an electrical connection that has a cost calculation to it, inventory number, etc. They would then all be listed here. And via the list of equipment, which also acts as a first evaluation function, you can then see the complete elements that are included in the visTABLE layout. I can expand the whole thing a bit by seeing the corresponding positions and dimensions here, and now the column for compressed air has been added here as well, and if I sort according to it, then the corresponding machine should be up here. I can then export the whole thing to Excel, for example. I can then give it to the MEP planner or the architect. I can also import it the other way around. Then you may have already discovered, in what we have now built here, there is also an attribute for the area type in the object properties. And to round off the geometric information, I'll go to the function of the area balance. If I zoom out, you will see the coloring of different areas and objects in the layout. On the right side, you will also have an overview with the total area and a pie chart. Below the overview as a list. Now we can see which area occupies the most space in our layout. Currently is the transport route. Seems that the layout could be optimized in that case. Of course, the areas open space are very interesting to look like here or here. Space costs money, so it's important to ask the question, how can I make better use of the areas or design the layout so that I also ideally use the areas in the corners or here at the edge? Now we have added objects here and they are not colored at all. This is because they are not on the reference area. I'm going to go to edit reference areas here, then you'll see the whole reference area. If I now extend the reference area here to this area, which could now be an extension of the building, for example, then the whole area is a bit bigger. I press apply. Now these objects are also in the reference area, and as you can see, the objects are then colored accordingly, Of course, the total area has now increased. Now we are at just under 6,000 square meters. And of course, the open space has now become much, much bigger because now the area here is not occupied at all. But as you can see, with the objects that we dragged in here, such as the machine or the assembly table, they are already pre-assigned in terms of colors. So the machine is assigned to the production type, the workbench is assigned to the assembly area. The object we have now created here is not specified because we have built it from a block element. And of course, this could either be assigned to a separate area type or to production. And then it should be displayed accordingly in blue after you have now briefly updated it here on the right side. Now you have a very good opportunity to use the one criterion of the area balance to determine the different layout variants and compare them against each other. Have you ever carried out an evaluation like this for your layouts? Or is something like the consideration of area in this form interesting to you?
No, we have never done something like that, but it is definitely very interesting, especially since it seems to be so easy to create the layout. Can I also create my own area types with custom colors, or is it just a standard set?
Yes, of course. Many companies have established and defined their own standards in this regard. We would now come to the point, which was perhaps already seen in the beginning, with regard to the next criterion for evaluating the layout variance, namely the transport effort and the material flow. Here, we already saw in the beginning that a few arrows passed through the layout. On the left side, now I can choose material flow, and I can toggle on and off what to see on the right. For instance, we can now see the material flows as a direct connection from the respective source to the sink. In other words, from where to where does a material flow go? And when you set up the layout, the ultimate intention is to design it in such a way that, of course, the transport effort is as low as possible. After all, you want to optimize your production while at the same time minimizing transporting products from A to B, because that doesn't generate any added value. So keeping the transport effort as low as possible is essential. To simplify this, the transports are shown here. How the whole thing is done and how the data gets in, I will explain right after. For now, you can see, by the width of the arrows, where your factory has the most transports per year. In the end, the width is a simple indicator. However, I can see directly where I have the most transports and should take this into consideration when putting or moving areas in my layout. Areas with thick transport routes should be put close next to each other to minimize transport distances, but then again, it gets more complex with the other arrows. But we'll get to that later on how best to approach this. The different colors of the arrows show which products or product families get transported. If it's multiple, then the arrows are shown as gray-black. Now the arrows were on the transport routes. When you import the layout, visTABLE does not automatically recognize this, but you have to define such transport networks yourself. This is just as easy as with the dimension arrows. As is now the case here, you can easily expand this for the forklift network by saying, okay, here the forklift has the opportunity to drive along these new lines. You have to define this once, so where can the forklift go, where can the worker go, etc. Once you have done that, visTABLE will automatically search for the shortest connection to the path network from the source. It takes the shortest route over the path network and then jumps down on the shortest connection. And once that has been done, then you can also hide the transport networks here, so you have a better overview. And via the logistics evaluation function, you can now see the corresponding transport effort and the effort also subdivided into the various transport systems. The transport effort is quite simple. How is it calculated? It is the number of transports multiplied by the corresponding path length. And if you do this for all products, then it ultimately results in transport effort in kilometers. In this case, here it is 6,700 kilometers. And here you can see again the proportions in the various transport systems. And if you connect the corresponding transport costs in euros per meter, then you can also switch here and see the whole overview on a cost basis. You can also filter everything according to the product families. So if I go to oil filter here, then you see the whole overview only for the oil filter. It is only transported with a forklift. and I also only see the arrows for the oil filter for the van highlighted in the layout. Have you ever analyzed your layout based on MFL aspects? Or how have you typically made decisions on where to place a new machine or a new area so far?
So far, we've just looked for the best available space. Regarding MFL, we've mostly done that based on intuition. For instance, we know where we have many transports, for example, for our high runners, and then we have generally based our decisions on that. But yeah, it would be great to know how high our transport workload is and where there are potentials for optimization. What actual information would we need as input for this?
Great question. That's exactly what I want to briefly show you in the next few steps. That's where we come to the place logics, where you can describe and define the whole thing. Alternatively, in addition to the manual method I'll demonstrate shortly, you can also import the data through your ERP system using an Excel table, which in this case would be the goods flow table. I'll jump in here to the oil filter. This is a fairly simple process, and here you can see the process steps that follow one after the other. We now produce 190,000 pieces of the oil filter per year. There is now a delivery, a test, milling, washing, and pre-assembly, and so on. You can now also note times here in the process so that you can do a very rough value stream analysis with regard to the throughput time. But because this does not necessarily have anything to do with the layout itself in terms of arrangement, you can also hide this part and limit yourself to the focus. How does the material get from A to B? In other words, from each process step to the next. You can have the number of transports calculated based on the transport lots, or you can enter them directly as a quantity. I'll show you how easy it is to create such a process here in the layout and creating a material flow. I want to realize this down here in the area and now show the process in logics. I give it a name, which I can freely assign for the process step. And when I see the box now, it's still gray. This means that it is not yet connected to an element in the layout. If I select the process box here and click on the pen, I get a list, an overview, with all the elements that I can now connect to this process box in the material flow. Now I want to choose a machine down here. I know this is the Chiron machine. I can enter the name here. Then it simplifies the selection for me. And now I have assigned the Chiron machine here. And now the box is also turning blue. So I know, okay, it's now connected to a layout element in the layout. If I go on here now and choose manual transport, so the worker transports one container each in his left and right hand, meaning he has two containers that he transports, and let's say there's 36 pieces in each container. Logics now shows me, based on this number, the worker would have to walk 2,639 times from the delivery to the Chiron machine. And if I now confirm this, then a new material flow arrow should be created in the layout, which we now see here. It now maps this transport, so that's how easy it is to create the material flow arrows in the layout. Now you'll be wondering, the arrow jumps right across the layout here. That's because the program is now looking for the shortest connection to the network of paths from the source. And the network of paths for manual transport only starts here, which is why it jumps over here at such an angle. Now on the right side, you can directly see the effects this has. In the case of manual transport, the effort is now extremely increased by 822%. That's because there weren't that many manual transports before. In total, you can see, it's only 3% in the end. This feature gives you instant feedback on your changes and evaluations. But in order not to destroy the layout now for the next step, I'll undo this again. It's just as easy to do by deleting the objects here via the gestures. The material flow arrow disappears, and we see on the right side, we are back to square one. And now comes the point where you see, okay, we have the various material flows in the layout now inside. We have the transport effort here, and we have also seen that the big thick arrows cross the layout. But so that this doesn't end in trial and error, we offer a layout optimization as a function in visTABLE that supports users in ultimately optimizing the whole thing. We now have different levels of area here. I'll now jump to the area level, where you can see which areas are connected to material flows. And we get a list on the right side that shows these areas and the according colors. which are then also stored in the layout according to the areas. And now it's relatively simple in terms of approach, either in an existing layout or in a new layout. The approach is, when you build the layout, then you look at it like an onion, and I start in the core with the red objects, incoming goods in warehouse, and the delivery. These are the two areas between which you have the most transports, and therefore I'm arranging them closest to each other first. And then I come to the third object, where I say, okay, now I've arranged the first two, then I'll take mechanical processing 3 and arrange it with the ones already arranged and so on. And if you set it up like this, then you get a layout where the transport effort is relatively low and everything is very optimally designed in this respect. In our situation, we would want to optimize the existing layout here. I'll just take the incoming goods warehouse here and arrange it here closer to the delivery. We see that the material flow arrow goes to the new position, and on the right-hand side up here, we have the value for the transport effort. In the beginning, we were at 6,700 kilometers, and now we already dropped down to 4,700 kilometers per year. So we saved 2,000 kilometers per year, which means almost 30% of the transport effort. When I now take the outgoing warehouse and move it to the top, we can decrease the transport effort even more. And so it is relatively easy to intuitively come to a good solution and get it supported accordingly via the list on the right side. The same principle can also be applied to the workstation area. Here as well, colors can help optimize the transportation effort. One last point to mention would be the grid network load. That's always a very exciting aspect, especially when you're on the road with forklift transports a lot. Of course, occupational safety is also a relevant factor in planning. Seeing the red here doesn't necessarily mean bad, but just indicates there's the most transports per year here. It also doesn't mean it is a lot or too much. But it should make me consider if there is an intersection or if there are curves close by where a lot of forklifts drive, there might be high potential to risk an accident. If I look at the data and realize a forklift drives by this area every 10 minutes, it might be smart to then optimize this area for safety. For instance, with blue spots on the forklifts so people see them coming, or increase the area to give it a better overview. All in all, these are the entire functions. A lot of information, but in my eyes, the optimal solution to a very complex endeavor. Planning a facility from start to finish can be a big challenge, and I think with tools and functions like these, it can definitely make the work process a lot better. But yeah, if you have any questions or anything is still unclear, feel free to ask away.
Yeah, thanks a lot for this great presentation. Was definitely quite a lot of information, but useful to know that there are so many features. It really seems like you covered all the features needed in the planning process, and even thought of things I might not have even considered until a problem arises. I can definitely tell that you have put time and effort into optimizing this tool for the end user. I do have a couple questions, though. Say I'd like to get started with the software, what kind of costs are associated with it?
Absolutely. If you're interested in getting the pricing details, you'll find everything you need on our website. Just head over to the shop area where you can explore different subscription models along with their associated costs. These costs vary depending on factors like subscription length and the number of users you require. But it's basically very simple and straightforward.
What about learning this program? I mean, it has extensive features, and I'm guessing you haven't used it for the first time to be an expert in it. How long does it take for me to actually use it as a tool?
Yeah, great question. When it comes to getting started with the software, we offer a trial period of 14 days. During this time, you can fully experience the software on your own with no associated costs. Like you already thought, I'm not necessarily demonstrating it for the first time. But I always emphasize its user-friendly and intuitive nature. To give it a shot, you can directly request the 14-day trial version from our website, and once downloaded, you can explore it at your own pace.
Yeah, I'll try that out and see how I can handle it. Are there certain PC requirements for the software? I'm not sure each department in my company has 3D rendering PCs and all of that.
Yes, I get that question a lot. There's two answers to this. Basically, a standard work PC will be able to handle the program. As a general overview, it's recommended to have at least an i5 processor, 8 GB of RAM, and a capable graphics card. But to get all the detailed ins and outs of our software's system requirements, the best place to look is our homepage. As our software involves working in 3D environments, having more processing power is particularly helpful for managing larger layouts. But don't worry, for regular usage, a standard PC or laptop will work perfectly fine.
Okay, that's good to know. Thanks for all the info. I really appreciate you taking the time to explain all this. I think that's all the questions I have for now, but I really think this is a tool that can help us in our company for planning and mapping out our production facility. I will be sure to check the website for the 14-day trial, and we'll take a look at all the costs.
Yeah, no problem. Thanks for jumping on the call. If you have any more questions, you can always contact us, and we will stay in contact during your initial start anyways. But for now, I wish you a pleasant rest of the day, and we'll talk soon.
Yes, thanks. Have a great day.
Goodbye.
Goodbye.